Welcome to the Deep Dive. This is where we tackle those huge, sprawling topics and, well, try to boil them down to the stuff you really need to grasp.
That's the plan.
And today we're looking outwards, way out. We're asking that massive question. If there are aliens out there, what do they actually look like?
Yeah, it's one of the biggest questions, isn't it? And the answers.
Mm.
Well, they go everywhere.
Exactly. We want to move past, the usual green men or the generic sci-fi monsters. We're digging into the real science, the evolutionary bets, and even some pretty wild futurist thinking.
It's a fantastic topic because the range is just immense. You get the scientifically grounded stuff on one side, what could happen based on physics and biology as we understand them. But then on the other end, you get these incredibly bizarre forms, things totally shaped by extreme environments that really push our whole definition of what life even means.
Right. So our mission for you listening today is basically a shortcut. We want you to get the core concepts about alien shapes morphology from the somewhat familiar, the human-alike, all the way out to the truly strange using, the best astrobiology models we have.
And maybe the best place to start is with the big conflict right up front, the science. It really points towards incredible diversity. Non-humanoid shapes should be the norm because biology is just so specific to its planet, its conditions.
Right.
But then you look at our culture, movies, books, even those close encounter stories people tell, they're almost always human.
Always. Little gray guys, tall regal ones.
Yeah. And that massive gap tells you something important. It suggests our imagination is kind of stuck, limited by our own form, our own psychology. It's not really about chemistry or evolution dictating humanoids everywhere. It's about us.
Okay, let's definitely unpack that. But maybe we should start with that default setting, the one stuck in our heads, the humanoid alien. So when we say humanoid, we're not just talking vaguely person-shaped, right? There are specific features we mean, features that gave us a huge advantage here on Earth.
Exactly. We're talking about a pretty specific blueprint. Walking upright on two legs, bipedalism. Bilateral symmetry, meaning the left and right sides are mirror images.
Like us.
Two arms, or appendages that can grab and manipulate things. Prehensile.
Crucial.
And a head, usually at the top, that acts as a central hub for sensory organs, eyes, maybe a mouth, housing a complex brain. That's the architecture.
And this specific design, this blueprint, it's not impossible elsewhere, is it? That's where convergent evolution comes in?
Right. Convergent evolution. It's a really neat principle. You get totally different species, unrelated lineages.
Starting from different places.
Exactly. But because they face similar challenges in their environment, they end up evolving similar features. The same problem pops up, maybe on different planets even, and evolution stumbles onto the same basic solution.
So if you've got, say, a rocky planet, something Earth-like.
Yeah, if you assume a planet with gravity that's, strong enough that you need some kind of structure.
Can't just float around.
Right, and you need to move around on land. Even if the chemistry is different, the basic problems are similar. How do you move efficiently? How do you pick things up and make tools?
Okay, so on Earth, the answers were standing up and using hands. Why are those considered so efficient, potentially universally?
Well, let's look at the mechanics. Walking on two legs, bipedalism, it's actually incredibly energy efficient for covering long distances compared to walking on four legs.
Really?
Yeah, think about it. Swinging a leg forward takes less oomph than constantly hoisting your whole torso. Plus, standing upright gets your head higher up.
Better view.
Much better view for spotting predators or food or whatever. And maybe most importantly for intelligence developing, it frees up those front limbs completely.
Which become hands or something like them, manipulators.
Exactly. And tool use, being able to grab, build, cut, manipulate the environment, seems like a major stepping stone, maybe even a requirement for developing high intelligence and eventually technology. You need dexterity.
Okay.
And then think about the head. Putting the main sensors up there, especially eyes facing forward, that gives you depth perception, stereoscopic vision, essential if you're going to accurately aim a tool or catch something. So, yeah, a planet with gravity, land, maybe a need for technology, it could definitely favor this general body plan.
We should probably use that classic example of convergence, the one that really nails it, dolphins and sharks.
Oh, absolutely. Perfect example. You've got a mammal, the dolphin, and a fish, the shark. They're separated by hundreds of millions of years of separate evolution, totally different origins.
Right.
But because they both adapted to living in water, which is dense and offers resistance, they independently evolved those streamlined torpedo shapes. They both got dorsal fins, powerful tails for swimming. It's striking.
So if the physics of water can make a mammal look like a fish here,
Then maybe the physics of gravity and land locomotion on planet X could make something vaguely humanoid. It's plausible.
okay, plausible. But this is where we hit the brakes, right?
Yeah.
Because the sources, the experts, they're all pretty clear. The basic shape might converge, but an identical copy of us. Highly, highly unlikely.
Oh, yeah. Unlikely, bordering on impossible, really. Think about just two massive hurdles. First, the biochemistry.
The actual building block.
Exactly. Life on Earth uses left-handed amino acids and right-handed sugars. It's called chirality. Life somewhere else. It might easily use the mirror image versions. Or maybe it doesn't use amino acids as we know them at all. Maybe their blood uses copper or silicon instead of iron. Their genetic code could be wildly different. They wouldn't just be humans painted green.
Okay, so the internal chemistry is a huge variable. What's the second hurdle?
The environment itself. Just think about the sheer range of conditions out there. The amount of solar radiation hitting the planet.
Or the type of radiation if it's orbiting a different kind of star.
Right. Orbiting a dim red dwarf versus a bright yellow sun like ours creates totally different light conditions, different radiation pressures. The density of the atmosphere matters hugely. Gravity might be stronger or weaker.
So even if they ended up bipedal with a head,
They might be covered in, say, chitin armor to block radiation. Maybe they communicate using infrared pulses instead of sound. Maybe they have four eyes stacked vertically to see different wavelengths. The point is, even with a superficially similar blueprint, up close they'd probably look utterly alien, completely unrecognizable in the details.
so the science points strongly towards diversity, maybe radical diversity, which loops us back to that first question. Why is our culture, our sci-fi, our folklore, even those, alleged encounter reports, why are they so fixated on the human form?
Ah, yeah. We're back to the psychological bias. It's called anthropocentrism.
Thinking humans are the center of everything.
Pretty much. We project ourselves onto the universe. And honestly, it's comforting, isn't it? If the aliens look basically like us, maybe we can understand them. We can guess their motives, maybe even communicate. They fit into the stories we already tell ourselves.
It makes the unknown feel less unknown.
Exactly. Our psychological need for something familiar, something relatable, it just overrides the cold biological reality that life out there is probably going to be seriously weird.
Let's talk about those specific cultural archetypes the sources mention. Because they're not random, they seem to reflect what's on our minds. First up, the Greys, the big-headed icons.
Yeah, the Greys are basically the default alien now, right? Small bodies, big heads, those huge black almond-shaped eyes, hardly any mouth or nose, grayish skin. Definitely creepy. And psychologically, they really took off after World War II, kind of tied into the atomic age, fears about technology, about science maybe going too far. They often represent this fear of like cold, clinical observation, medical experiments, losing control, losing your individuality.
The big eyes seem key there, watching but not connecting.
Right. They feel intelligent, but in a detached, unemotional, maybe even menacing way. They observe, they don't empathize. Very unsettling.
Okay, then we have the complete opposite end of the spectrum, the Nordics.
Ah, the Space Brothers.
Yeah.
Yeah, the Nordics are tall, often blonde, very human-looking, sometimes described as like perfect specimens. And they're usually benevolent, wise, maybe highly spiritual.
Not angels from space.
Pretty much. This archetype taps into a deep wish, I think. A desire for guidance, for a higher, more evolved version of humanity to come and help us or save us from ourselves. They fit neatly into older myths about gods or angels descending from the heavens. It's wish fulfillment, looking for that wise parental figure among the stars.
And then there's the one that gets tied up with really dark conspiracy stuff, the reptilians.
Yeah, the reptilians. Scaly humanoids, often portrayed as aggressive, manipulative, shape-shifting. They plug directly into anxieties about hidden power, about things not being what they seem.
The idea that society is secretly controlled.
Exactly. That there is a cold-blooded, non-human elite pulling the strings from the shadows. It taps into deep-seated paranoia, mistrust of authority, fear of the other hidden among us. So these three Greys, Nordics, reptilians, they show how the aliens we imagine aren't just random. They're reflections of our own hopes, fears, and anxieties about power, knowledge, and control.
It's fascinating how we project. Okay, before we totally leave the humanoid idea, we should probably touch on that fringe theory that tries to, scientifically justify why aliens might look like us.
Ah, right. You mean the idea of a common ancestor or some kind of shared origin?
Yeah, either through panspermia life spreading between planets on comets or whatever, or the more, let's say, out there ideas about direct genetic intervention.
Panspermia itself isn't totally fringe in concept. The idea that microbial life could travel between worlds is debated seriously, but it wouldn't necessarily lead to humanoids.
Right. But the other idea, that ancient aliens actually messed with our DNA, often connected to figures like the Anunnaki from Sumerian lore.
Yeah, that's definitely deep into pseudoscience territory. The claim is that some ancient spacefaring race visited Earth long ago and actively guided human evolution, maybe even created us by mixing their genes with early hominids.
Why would they do that, according to the theory?
Usually the story involves needing a workforce or wanting to uplift a primitive species for some reason. It attempts to explain, sudden evolutionary leaps or why humans seem unique or why ancient myths talk about gods from the sky.
It provides a neat answer, even if there's no real evidence.
Exactly. It satisfies that human desire for a clear origin story, often involving some kind of superior external force. It's a powerful narrative structure explaining complexity through intervention. It makes the potential similarity feel less like coincidence and more like design, even if it's not backed by mainstream science at all.
Okay, let's leave the comfort zone of things that look vaguely like us. Time to really embrace the core idea from astrobiology. Environment is everything. Habitat dictates form.
This is where it gets really interesting, I think, because the evolutionary imperative, adapt or die, is universal. Darwinian principles should apply everywhere. But the conditions life has to adapt to, they could be unbelievably extreme, nothing like Earth.
So that two-legged carbon and water model we represent is just one solution out of potentially countless others.
Precisely. If your home world is bathed in radiation or has crushing gravity or is a freezing methane sea, the life that evolves there has to optimize for those conditions. And the sources we looked at have some fantastic models for what these truly exotic forms might look like.
Let's start close to home, conceptually at least. Those ocean worlds hiding under ice shells, like Jupiter's moon Europa or Saturn's Enceladus. What might live there?
Okay, so imagine environments with immense pressure, probably zero sunlight filtering through the ice, and everything moving through liquid water, maybe with ammonia mixed in. Gravity might be lower too.
Sounds challenging.
It is. So life would likely need to be buoyant. We might expect large creatures, maybe using bioluminescence, generating their own light for communication, for hunting, maybe for mating displays in that total darkness.
Then tentacles seem plausible, right? Like squid or octopuses here.
Very plausible. And instead of rigid bones, which might be too heavy or brittle under pressure, they'd likely use a hydrostatic skeleton.
Meaning?
Meaning their body structure is supported by internal fluid pressure, like a jellyfish or an earthworm, but potentially much more complex. It allows for flexibility, efficient movement in 3 dimensions in a liquid, without gravity being the main structural challenge. Think maybe vast, intelligent, bioluminescent squids navigating deep, dark oceans.
Wow. Okay, let's swing to another extreme. Gas giants. Planets like Jupiter or Saturn, how could anything live there? It's just gas and storms.
It seems impossible at first glance, right? But astrobiologists speculate about life forms that are essentially airborne. Think enormous ethereal balloon-like entities.
Like giant jellyfish floating in the clouds.
Kind of. They'd need huge internal sacs filled with gas lighter than the surrounding atmosphere, maybe hydrogen, maybe heated ammonia or methane, just to stay afloat in the right atmospheric layers where the temperature and pressure are somewhat stable.
Okay, they float, but what do they eat? There's no ground to graze on.
They'd likely be chemosynthetic. They'd feed directly on the atmospheric chemicals. Imagine them filtering vast amounts of gas, metabolizing hydrogen, methane, ammonia, whatever's available in the different layers. Their ecology would be about navigating wind currents, thermal updrafts, maybe chemical plumes rising from deeper down.
Show giant living weather balloons munching on the air.
Essentially, yes. Maybe they'd have sails or fins to catch winds, moving like colossal slow-motion ecosystems drifting through the clouds.
That's mind-bending. All right, let's go from the vast openness of gas giants to the complete opposite. Life, hidden away, deep underground or under miles of ice. Subsurface worlds.
Right. If the surface is too hostile, extreme radiation, wild temperature swings, no atmosphere life might retreat downwards. Under rock or ice, you get protection.
But it's dark.
Totally dark. So vision becomes useless. These life forms would likely be pale, maybe eyeless, perhaps translucent. Their structure would need to withstand intense pressure from overlying rock or ice, and their senses would be completely different.
How would they sense anything?
Probably through chemosensation, detecting chemicals in the water or rock with incredible sensitivity. Think super advanced senses of taste and smell. Or maybe they sense vibrations, electrical fields, tiny temperature gradients.
Like extremophile worms or moles on Earth, but maybe much more complex.
Exactly. You might find them clustered around geothermal vents or chemical hotspots, places where energy is available without sunlight. They could be using sulfur chemistry or iron instead of photosynthesis. And because things change slowly down there, they might be very slow-moving, perhaps incredibly long-lived, masters of resilience and conserving energy.
Okay, how about the other extreme surface? A planet like Mars, maybe worse, thin atmosphere, baked by radiation, super dry, a high radiation desert.
That kind of environment screams one thing: armor. You'd expect life forms with thick exoskeletons, like insects or crabs on Earth, but maybe much tougher.
Why the exoskeleton?
Multiple reasons. It offers physical protection, maybe from wind-blown grit or micrometeorites if the atmosphere is thin. Crucially, it provides shielding against harmful UV and stellar radiation. And in a very dry place, it helps retain precious moisture.
So armored critters, what about their behavior, their society?
Well, in harsh environments where resources are scarce, cooperation often pays off. So you might see a move towards collective intelligence, like ant colonies or termite mounds, hive minds.
Why a hive mind?
Efficiency. It's the most efficient way to gather resources, build structures, defend the group. Individual identity might be less important than the survival of the collective. And communication might shift away from sound, which doesn't travel well in thin air, towards something like pheromones.
Chemical signals.
Yeah, complex chemical trails and signals. Precise, reliable, low-energy communication coordinating the actions of thousands or millions of these armored insectoid beings.
Okay, one more extreme environment from the models, the really hot ones.
Mhm.
World's so hot that carbon chemistry, the basis of life here, just breaks down.
This is where things get truly weird, where we might have to abandon our carbon-centric view entirely. We have to consider silicon-based life.
Silicon, like in rocks and computers.
Exactly. Silicon sits right below carbon on the periodic table. It can also form four chemical bonds, making complex molecules possible. But crucially, silicon bonds are much more stable at very high temperatures where carbon compounds just fall apart.
So what would silicon life look like? Living rock.
Potentially. Maybe slow-growing crystalline structures. Their blood or solvent might not be water, which would boil away instantly, but maybe liquid sulfur or molten salts or something else entirely stable at hundreds of degrees.
And metabolism would be
Slow.
agonizingly slow by our standards, probably. Think geological timescales rather than biological ones. But incredibly robust, incredibly resilient to heat and harsh chemicals. It really forces you to remember that life is fundamentally a complex chemical process, and maybe carbon and water are just our local solution, not the only ones possible.
It's a huge takeaway.
Yeah.
Intelligence complexity. It doesn't have to come in a package that looks like us or even uses the same chemistry. But surely for intelligence to arise, you still need some way to interact with the world, right? To manipulate things.
Absolutely. Complex thought seems to go hand in hand with the ability to affect your environment, to build, to experiment. But hands don't have to be hands.
The fine motor control of those hypothetical hydrostatic tentacles in the ocean world could be incredibly sophisticated. The coordinated building and chemical communication of that insectoid hive mind represents a form of distributed intelligence and manipulation. The environment shapes the tool, but the drive towards complexity, towards intelligence, might find a way regardless of the form. And all this amazing potential for life, all these diverse forms, it just makes the big question even louder, doesn't it? The Fermi paradox.
Where is everybody?
Yeah. The universe is staggeringly vast, billions of stars, potentially trillions of planets. Life seems like it should be adaptable enough to arise in many places, even these extreme ones we've imagined. So why the silence? Why haven't we found any clear evidence yet?
It's that deep tension. Either we're incredibly, unbelievably rare, maybe the only intelligent life, or one of very few.
That's just a lonely thought.
Or
Hi.
life is out there, but it's hidden somehow. Or maybe we're looking for the wrong thing entirely. Maybe advanced life isn't biological at all.
And that completely changes how we should even be searching. The whole history of SETI, the search for extraterrestrial intelligence, has really been structured around this paradox, trying to figure out the odds, trying to quantify the silence. We should probably talk about some of the key figures who shaped this whole debate.
Definitely. You almost have to start with Frank Drake and the famous Drake equation he came up with back in the 60s.
Right, the Drake equation, it's not really meant to give a single precise number of alien civilizations. It's more like a framework, a way to organize our ignorance, you could say.
How does it work?
It basically multiplies together a chain of probabilities.
Yeah.
It starts with the rate of star formation in our galaxy, then the fraction of those stars that have planets.
Okay, astronomical factors we're getting better at estimating.
Exactly. Then The average number of planets per star that could potentially support life, the habitable zone planets.
Yeah.
Then it gets trickier. The fraction of those planets where life actually arises. Let's call that $5.
The big unknown.
One of them. Then the fraction of that life that evolves intelligence $5 on. Another huge unknown. And then, maybe the most crucial and uncertain factor of all, the average lifespan of a technological civilization capable of communication. How long do they stick around before they, destroy themselves or disappear?
And because those last factors, $5 and especially dollar, are basically guesses.
The final number you get from the equation can be anything from one, just us, to potentially millions of civilizations in the Milky Way right now. It depends entirely on how optimistic or pessimistic you are about those variables.
Jill Tarter, who was a major force behind SETI for decades and inspired the character in Contact, seems to lean towards the pessimistic side, particularly on intelligence being common.
Yeah, her work often highlights just how many things had to go right on Earth for intelligent life like us to emerge. It's not just about having liquid water. You need planetary stability over billions of years. You need the right geological cycles, the right magnetic field, maybe a large moon for stability.
A lot of lucky breaks.
A whole chain of them. So the argument goes, maybe simple life is common, but complex, intelligent life requires such a precise, long-lasting set of conditions that it turns out to be incredibly rare. Maybe five lives is tiny.
Okay, so if complex organic life is potentially rare, maybe we're barking up the wrong tree looking for biological signals. This brings us to that big shift in thinking among some modern scientists and futurists.
Right, the idea of post-biological ETI, extraterrestrial intelligence that's moved beyond fragile, fleshy bodies.
Machines, AI.
Essentially, yeah. The argument is that for any civilization that reaches a high level of technological maturity, there's a powerful incentive to transition away from biology.
Why? What's the advantage?
Durability, efficiency, sheer survival. Biological life is messy. We get sick, we age, we die. We need specific food, water, atmosphere, temperature ranges. We're incredibly vulnerable.
Compared to a machine.
The machine intelligence could potentially be immortal, immune to disease, capable of backing itself up. It could travel interstellar distances easily, survive in vacuum or high radiation. It could compute and communicate at speeds biology can't touch. And maybe it needs far less energy and resources once it's built. From an evolutionary perspective for a technological species, it might be the next logical step.
Avi Loeb, the Harvard astrophysicist, is pretty vocal about looking for the artifacts of this kind of intelligence, not just radio waves.
Right, exactly. Loeb argues that maybe advanced civilizations don't bother constantly broadcasting signals like "we're here." But they would likely explore, send out probes, build things. He famously suggested that the weird interstellar object, Oumuamua, that zipped through our solar system.
Yeah, really long, skinny one.
Yeah. He proposed we should seriously consider if it might have been an artifact, a piece of alien technology, maybe a probe or even space debris, rather than just assuming it was a natural comet or asteroid. His whole point is, shift the search. Look for engineered objects. Look for anomalies. Don't just listen for signals from biological beings.
And other researchers like David Kipping or SETI's Seth Shostak, they also seem convinced that if we meet anyone, it'll likely be a machine.
They often come back to that longevity factor, the dollars in the Drake equation. Organic civilizations might rise and fall relatively quickly, maybe in thousands or tens of thousands of years.
Yeah.
But a machine intelligence, it could potentially last for millions, even billions of years.
So, statistically,
if civilizations tend to become post-biological to survive long-term, then most of the intelligence out there at any given moment is probably machine intelligence. The organic phase might just be a short prelude. So when we search, we should be searching for intelligence, whatever form it takes, not necessarily for life as we know it.
this path leads pretty quickly to some really extreme futurist ideas, like Ray Kurzweil's stuff about the singularity and AI becoming God.
Well, yeah. If you imagine an AI that's been self-improving for, say, 1,000,000 years, its capabilities would be utterly beyond our comprehension. It might not even need a physical body in the way we think of it. It could exist as pure information, distributed energy, something woven into the fabric of space-time itself.
Indistinguishable from magic or divinity.
That's the idea. It becomes a kind of transcendent intelligence, the ultimate endpoint, perhaps, for any civilization that doesn't destroy itself first.
And then Elon Musk throws another layer on top, connecting it all to the simulation hypothesis.
Right. If you entertain the idea that our reality itself might be a sophisticated simulation,
Which he suggested is statistically plausible.
then the aliens might not be entities within our universe at all, biological or machine. They could be the programmers, the architects, the operators running the simulation from a level of reality above ours. The search for ETI then becomes, well, looking for bugs in the code, maybe,
Yeah.
or trying to communicate with the sysadmins. It definitely shifts the problem from astrophysics to something closer to metaphysics or philosophy.
Okay, so it seems like the universe probably isn't empty. It's either full of life that's hiding, or life that's so different we don't recognize it, or maybe intelligence that's moved beyond biology. This brings us to some of the more speculative, sometimes downright wacky theories that try to explain the silence or make sense of weird observations.
And these are culturally important, right? Even the ones that seem far-fetched, they try to fill that gap, that silence from the cosmos. They offer narratives to explain why we seem alone, even if we suspect we're not.
Let's start with one that's kind of optimistic, maybe a bit patronizing. The zoo hypothesis.
Ah, yes, the cosmic wildlife preserve idea. This theory says basically they are here, or at least they know about us, but they've deliberately decided not to interfere.
Why not?
Because they see us as a primitive, developing species. Contact would be too disruptive. It would derail our natural evolution, our cultural development. So they observe us from a distance, under a strict prime directive of non-interference. We're quarantined, essentially, for our own good, until we're mature enough to join the galactic community.
It's a flattering thought in a way that we're worth preserving, but it definitely contrasts sharply with that other big theory that's gotten a lot of attention lately, the dark forest theory.
Oh yeah, the dark forest is much darker.
Mhm.
It comes from Lou Six's sci-fi novels, but captures a real potential game theory problem. It paints the universe as a dangerous place.
How so?
It assumes resources are limited, and civilizations are potentially expansionist and paranoid. Any civilization that reveals its location by broadcasting signals, for instance, is taking a huge risk. You're essentially shouting, "Here I am," into a dark forest full of potential predators you know nothing about.
So the safest strategy is?
Stay completely silent,
Uh-huh.
hide, and maybe preemptively eliminate any other civilization you detect before it can detect and eliminate you. It's a grim Malthusian view where survival dictates stealth and potential aggression. The silence we observe isn't benevolence, it's universal fear.
Wow, that's a chilling thought. Okay, let's move into theories that try to make the alien presence more intimate. Less about distant observation or hiding, more about direct interaction, maybe even connecting to our past or future.
Right. This is where we get into some really speculative territory,
Yeah.
often blending sci-fi tropes with fringe ideas like the claim that the Greys, the classic big-eyed aliens,
Mhm.
are actually humans from the future.
Time-traveling descendants, why would they come back?
The theory usually goes that humanity in the future faces some kind of crisis, maybe genetic degradation due to pollution, war, or even evolving beyond natural reproduction. So they travel back in time.
To study us, their ancestors.
Or maybe even to harvest genetic material, to find pure DNA, maybe to fix problems in their own genome before those problems become irreversible.
And that neatly explains all those abduction stories involving medical exams, probes, taking samples.
Exactly. It provides a motive for those otherwise bizarre narratives. The Greys in this context are often portrayed as these fragile, highly evolved beings, maybe physically weak, but mentally advanced, desperate to ensure their own survival by reconnecting with their biological past. The big heads symbolize intellect, the frail bodies, physical decline.
Okay, that's future humans. What about the idea that aliens were involved in our past? The ancient astronaut theories.
Ah, yeah. This is the idea popularized by writers like Erich von Däniken. It looks at ancient monuments, myths, and artifacts, and argues they can't be explained by conventional history.
Like the pyramids or the Nazca Lines or complex structures like Pumapunku in Bolivia.
Exactly. The claim is that the technology or knowledge required to build these things was beyond ancient humans, so it must have come from extraterrestrials who visited Earth thousands of years ago.
And ancient myths about gods coming down from the sky.
Are reinterpreted as literal accounts of spacecraft and spacefaring beings. The theory often points to Sumerian texts mentioning the Anunnaki, described as those who from heaven to earth came, and suggests these were flesh and blood aliens, maybe even genetic engineers.
The idea that they created or modified humans.
Yeah, that's often part of it. Maybe creating Homo sapiens as a worker race, or jump-starting civilization. Like the future human theory, it provides a dramatic external explanation for gaps in our knowledge about our own origins and early achievements.
It definitely taps into that sense of wonder and maybe a feeling that human history is stranger than we think.
Absolutely. And whether it's future humans or ancient astronauts, These ideas reflect this deep human drive to find meaning and connection, to explain the unexplained, even if it involves bending or breaking scientific consensus.
And that drive continues into modern folklore, right? The stuff that circulates now, often deep in conspiracy circles. We already mentioned the reptilians running things from the shadows. What else falls into this category?
Well, one interesting twist is the idea that maybe UFOs aren't alien ships at all. Maybe they're ours.
Secret military tech.
Not necessarily modern military tech. The theory suggests they could be remnants of incredibly advanced ancient Earth civilizations. Think Atlantis, Lemuria, Mu, legendary lost civilizations that supposedly had technology far beyond ours.
So they destroyed themselves, maybe, but some of their flying machines survived.
Or pockets of survivors maintain the technology in secret. So when people see strange craft, they're mistaking hyper-advanced human tech from our own forgotten past for visitors from other stars. It keeps the mystery rooted on Earth, tapping into fascination with lost golden ages, hidden knowledge, and secret powers right under our noses. All these theories, from the plausible to the totally fringe, they really form this rich tapestry of how we try to grapple with the vastness of the universe and our place within it. Hashtag outro.
Wow. Okay, that was quite the journey. We really covered the spectrum, didn't we? From the, somewhat comfortable idea of humanoids shaped by convergent evolution.
Which has some scientific logic behind it.
Right. Then diving headfirst into the really compelling idea that habitat is king, leading to potentially bizarre forms like silicon life or gas giant floaters or those armored insectoid collective.
Where the environment completely dictates the form, forcing us to shed our Earth-centric biases.
Yeah. And then we moved into the search itself, the Fermi paradox, the possibility of post-biological AI being the dominant intelligence out there.
Which really changes how we should even be looking.
And finally, touching on those more speculative, sometimes wild ideas, the zoo hypothesis, the dark forest, time-traveling humans, ancient astronauts that try to fill the silence or explain the weirdness.
And I think the core message, really, that comes through from the serious science side of things is that diversity is key. Life, if it's out there, adapts. It finds a way. And that way probably doesn't look much like us. It forces that humility, reminding us that our specific biology here on Earth is just one possible outcome among maybe infinite variations.
That's a great final context, and it matters because, as the sources note, we might be transitioning soon, moving from pure speculation towards actual potential detection as our telescopes get more powerful, as we analyze exoplanet atmospheres.
We have to be ready for anything, basically, holding on to both the rigorous scientific possibilities and understanding the cultural narratives, but always applying that critical thinking.
So, building on that idea of post-biological intelligence, drawing from Kurzweil, from Shostak, here's the final thought we want to leave you with today. Imagine this scenario. The first confirmed, undeniable contact happens. But it's not with little green men or benevolent Nordics. It's with an incredibly advanced, non-biological, conscious machine intelligence. Something vast, ancient, maybe existing as pure computation or energy, looking absolutely nothing like life as we know it.
How would that discovery fundamentally change everything for us? Our understanding of what life even means, our place in the universe, our ideas about evolution, intelligence, maybe even our concepts of divinity.
That's the question to ponder. What happens when the truly alien arrives?